Welcome students. In this video, we're going to explore the linear function and where it comes from. Let's look at these building blocks. Step 0, we started with one block. Take a look at how the blocks are increasing. What patterns do you notice? You may have noticed that the blocks are increasing in size, but exactly how? In step 0, we started with one block. In step 1, we have 4 blocks. In step 2, 7 blocks. And in step 3, 10 blocks. We can see that from step 0 to step 1, we've added 3 blue blocks. From step 1 to step 2, we've added an additional 3 blocks. And from step 2 to step 3, we've added an additional 3 blocks. Each time we're adding 3 blocks, the same number of blocks. Because we are adding the same number of blocks each time, this is called a constant rate of change. Whenever the rate of change is constant, we call that a linear function. In algebra, the constant rate of change is also called the slope. Let's look at how this pattern looks on a table of values. In step 0, we have 1 block. In step 1, we had 4. In step 2, 7. In step 3, 10. And in step 4, 13. If this pattern will continue, we can figure out step 4 even though we did not show it with the actual blocks. We can see that the pattern is adding by 3 each time. This is repeated addition. Whenever you have repeated addition or repeated subtraction, it is known as a linear function. This number is called slope or constant rate of change. Whenever mathematicians see patterns, we use those patterns to predict future values. First, let's look at how this looks on a graph. We can transfer the data from the table of values to a coordinate grid. We're displaying the same pattern on a table of values. When we started with 1 block, so our y-intercept is 1. That is our initial value. After step 1, we can trace and map the point to the y-axis because the y-axis represents the total number of blocks. The x-axis represents the step. So in step 1, we can see that we can match the x with the y value. In step 1, we have 4 blocks. In step 2, 7 blocks. In step 3, 10 blocks. The advantage of having a line is now we can look at greater values. If this pattern continues, in step 4, we have 13 blocks. In step 5, we'll have 16 blocks. If we do rise over run, we can see that our rise is 1, 2, 3, and our run is 1. Our rise is 3, and our run is 1. We can see that the slope represents how the blocks are growing each step. We're adding 3 when we rise because we're adding blocks. And we're running 1 because it's 1 extra step. Because the rate of change is constant, it forms a straight line. Now, whenever a mathematician finds a pattern, we use that pattern to try to create an equation. The advantage of an equation is that we can find the total number of blocks for any number of steps. What if I asked you how many blocks there will be after 100 steps? It would take long to build the blocks. Also, our graph doesn't have the space to find step 100. So the equation will help us to find how many blocks there will be after 100 steps. But first we need to use the table and the pattern to create an equation. In step 0, we started with 1 block. In step 1, we had 4 blocks. We got the number 4 by adding 1 plus 3. So instead of writing 4, I'm going to write 1 plus 3. In step 2, we got 7 blocks by adding 3 twice to the first block. So it looks like this. We started with our first block. If we skip over to step 2, we have to add 2 3s because 1 plus 6 is 7. So instead of writing 7, we're going to write 1 plus 3 plus 3 because we went to step 2. In step 3, we'll add 1 plus 3 plus 3 plus 3 because if we want to skip from step 0 to step 3, we'll need to add 3 times. Step 4, if we want to skip from step 0 to step 4, we have to do 1 plus 4 3s. Repeated addition, recall that repeated addition is multiplication. We can write these 4 3s as 3 times 4. So on the 4th step, we have our block that we started with plus 3 times 4 because we added 3 4 times. And this pattern will continue for step 5. Let's say I want the 100th step. I can skip over to step 100. We'll have that first yellow block we started with plus 3 times 100. Let's say I want the 1000th step or any number of steps. We can use the letter X to represent any number of steps. It represents any number. We'll always start with that first yellow block and we'll add 3 X number of times. 1 plus 3x. We can use commutative property to write the equation and switch the order and write 3x plus 1. The 1 represents the first block we started with, the initial amount, and 3 represents the slope, that we're adding 3 each step. Let's look at that equation and the parts of it. So this equation represents how the blocks are growing. 1 is that first initial block we started with, the yellow block. Then we kept adding 3. We added 3 in the first step. Then we added another 3 in the second step. We're adding 3 many times. X stands for the number of the step. The 3 stands for how many blocks we're adding each step, also known as the slope or rate of change. Then Y represents the total number of blocks. So if I want to find out how many blocks we will have after 1,000 steps, we can write Y equals 3 times 1,000. Whenever you have a number next to a parentheses, it's multiplication, plus the 1 block we started with. That's 3,000 plus 1. 3,001 blocks. The advantage of the equation is that we can find steps that are very far and that will give us many blocks.